Okay, let's review systems of equations. Now, there's a lot of this that would be really, really helpful on a graphing calculator, but I'm going to cover that in another video. But if you have a graphing calculator, please go ahead and watch that video, as it's going to be much more easier for you to follow than this. Now, if you don't have a graphing calculator, you can still do all of this. It's just not going to be quite as fast or quite as easy, but you are capable of it. Really, when it comes down to like the last 4 questions or so here, that's when it starts to get pretty tricky. But let's start by talking about what systems are. Now, this is a system that you see on your screen. Doesn't look like a system that we're used to. We talked about systems a while ago, and when we talked about them, we had them just as 2 lines on a graph. And the answer to the system was the point where the 2 lines met. So the answer to that system would be right here. Okay, whatever that point is. But that's the key to a system. It doesn't really matter. It doesn't have to be 2 lines, though. It could be anything, but the solution is where the lines cross each other. So in example number 1, it's pretty straightforward. There's not a whole lot of work to do. But I just want to look, and the answer is going to be where the lines cross each other. So I've got that circle, oval looking thing. I've got a line that goes through it. So the answer to this system, quote unquote, is where those 2 are intersecting. And there's 2 points where they're intersecting. There's intersecting once right here and once right about here. And so those points are the solution to the system. All we got to do is write down the ordered pairs. So this point looks like it's at 1 on the x-axis and 2 on the y-axis. So that looks like it's the point 1, 2. And then this one down here looks like it's the point, let's see, 2 on the x-axis and then negative 2 on the y-axis. So these are the 2 solutions to that system because simply that's where those cross. That's all the system is. It's where the lines cross, which is why on a graphing calculator this will be a lot easier because we'll be able to graph our systems, see where they cross, and then call it a day. But if you don't have a calculator, doing this by hand is much longer. But we're still capable of it, okay? But so the answer to this one is option 1. All right. Now I've got to erase this as I scroll on down. All right. This is the same exact question pretty much. It's asking you what is the solution to that system. And it's the same principle, okay? It's a line, it's a quadratic, it doesn't really matter what it is. The solution to the system is where those functions or where those shapes or lines meet up. And it looks like these 2 intersect at about 1 point right here. That's where they're going to intersect. That point is going to be the solution then. So that point looks like it's about the point 1, negative 3. All right. So the question's a little bit worded weird because it doesn't want the specific point. It's just what is a solution to that system. Oh, I'm sorry. Well, that is the solution to that system, but I misread the question. It says, what is most likely the number of solutions? And as you can see, there's only 1 point of intersection that they cross, so there's only going to be 1 solution here. That was what the question was asking for, but I gave you a little bit more than you bargained for. Pro tip, everybody just read the questions carefully. There's only 1 solution to the system, by the way, because there's only 1 place where those 2 different equations meet, where they intersect. Okay. Because again, the solutions are where they intersect. All right, this one. What is the apparent solution set to the system of equations shown on the graph? Now, on this one, again, the solutions is where they meet or where they intersect. And you can see on this one, there's kind of a gap in between them here. These 2, the parabola and that line, do not cross each other. They do not intersect. So this is going to have no solution, simply because there is no point of intersection. All right, this one, same idea. It's 2 lines. It's kind of what we're more familiar with. What is the solution to the system? Again, the solution is where the lines intersect. And that's right here. And that seems to be the point negative 1, 2. All right. Now here's where it gets a little tricky. And here's where the bulk of the video is going to be in terms of working all this stuff out. I'm going to need some space to work it out. So let's see. I'll figure something out here. Maybe I can Alright, anyway, forget all that. Kaiko determined that the coordinate points -4, 0, -3, -1, 2, -6 are solutions to the following system. Which coordinates from the solution set are reasonable solutions to the system of equations? So it looks like this guy Kaiko, that's how you say his name, has already solved this system, so we don't have to. It's what we need to do is figure out if he's correct or not. So he's determined that -4, 0, -3, -1, and 2, -6 are solutions to the system. What we can do to check is simply plug these in for x and y, and all three of them, and see which ones work, see which ones don't. So let's start with that. Let's start with the first point, it's -4, 0. So if we plug in -4, 0, we have to plug them into both equations, by the way. The first equation would be, is currently y equals -x minus 4, but if we plug in 0 for y, and then -4 for x, this would be 0 equals, this would be a positive 4 minus 4, which would come out to 0, so we'd have 0 equals 0. So it works for the first equation. Let's see if this same point works for the second equation. The second equation is y equals x squared plus x minus 12. We're just going to plug in 0 again for y, and then -4 for x. Notice we're plugging it in twice here because there's two places to plug in x. But we're just plugging in the numbers and then evaluating. So we'll have 0 equals -4 times -4 is positive 16. And then this will just be -4, and this will be -12. So we have 0 equal to 16 minus 4 is going to be 12. And then 12 minus 12 would be 0, so it works there as well. So that point works. -4, 0 works. So it's definitely not going to be option 4. At least we know that. It's going to have at least -4, 0, which option 1, 2, and 3 definitely have. So let's erase that. Now let's try another point. Again, we're just going to repeat this process one or two more times. We'll see what we need to do. Because of the answer choices are multiple choice. So let's see. I guess we do have to test all three of them out. So let's test all three of them out. So the equation y equals -x minus 4. That's the first one, right? Now we're going to plug in -3 for x and -1 for y. So we'll have -1 equals -3 minus 4. So this would be -1 equals a positive 3 minus 4, which is -1. So that works. Now we need to check the second equation to see if that also works. Second equation is y equals x squared plus x minus 12. Alright, so we're plugging in -1 for y and -3 for x. Let's see, minus 12. So let's see, this would be -1 equals, -3 times -3 is positive 9. This would be -3 minus 12. Now this doesn't look like this will work because 9 minus 3 is 6, and 6 minus 12 would be -6, not -1. So this one would be -6, or -1 equals -6, which is not true. So it doesn't work for the second equation here, which means it's not going to work at all. So -3, -1 is not going to work. Alright, so it's definitely not answer choice 3 then. Alright, we could just take 50-50 if we wanted to, but let's check this last one to see if it works. We're going to plug in 2 for x and then -6 for y. So we'll have -6 equal to -2 minus 4. So this would be -6 equal to -2 minus 4, which is -6. So it does work there as well. Now let's check the other equation. Y equals x squared plus x minus 12. Let's see, we're plugging in -6 for y, and we're plugging in 2 for x. So plus 2 minus 12. Alright, let's work this out. We'll have 2 squared is 4. This will be plus 2 minus 12. Oh, I wrote 16. Didn't mean to write 16. Minus 12. Alright, so let's just evaluate. 4 plus 2 is going to be 6. 6 minus 12 is going to be negative 6. So it does work in the first equation. It does work for the second equation. So those 2 points work. So the answer is going to be option 2. All right. Now things get a little bit tricky. We're going to use elimination on this. Again, if you have a graphing calculator, this would come in handy. It's going to be much faster. But if you don't have a graphing calculator, let's go ahead and work this one out. So we have x squared plus 4x plus 3, and then y equals x plus 1. And we need to solve this. So what we're going to do is sort of use the elimination method that we've had in the past. So let me rewrite, let's see here, hold on, maybe let me make this a little bigger. Alright, I'm going to use this entire right side here to sort of work the problem out. I might need a little bit more than that, but we'll see. Alright, so let me rewrite these equations. I have y equals x squared plus 4x plus 3. And then what I'm going to do is I'm going to write the next equation sort of in the same layout. You'll see what I mean. The next equation, y equals x plus 1. Now I've left a gap here because what I'm going to do is I'm going to subtract this equation from one another. So I'm going to subtract my second equation. And I left a gap because there's no x squared in the second equation. So I left that space blank because we'll be subtracting nothing then. Well, let's subtract. If I have a y minus a y, that's going to be 0. Now x squared minus nothing is still going to be x squared. Now here, you have to be careful because we are subtracting. So remember that you're subtracting. That's 4x minus x, which is going to be 3x. Right? Because 4 minus 1 would be 3. And the same thing on the last one. It's 3 minus 1. You have to remember you're subtracting everything here. 3 minus 1 is 2. So that's our equation. Now, there's two ways you can go about this. One's the quadratic formula. Remember, this would be a equals to 1, b equals to 3, and c equals to 2. All right. But we're not going to do it that way. We're going to do it by factoring. If you remember how to factor, it's going to be a little bit faster, but you can use quadratic formula if you want to. But we're going to factor. Remember factoring? It's a times c up here and b down here. A times c, you have 1 times 2, which would be 2, and then the b is a 3. Alright, so I want two numbers that multiply to 2 and add to 3. The only numbers that do that is 2 and 1. 2 times 1 is 2. 2 plus 1 is 3. So this, if I factored it, would become x plus 2 and x plus 1. Alright, now what you do is you take both these groups and have them equal 0, right? If you kind of cover one up, like let's pretend, I don't know if there's a way I can do this. There might be a way I can do this. If you cover one up, you have x plus 2 equals 0, and let's go ahead and solve that equation. X plus 2 equals 0. Let's do that over here. Oops, writing the rectangles now. I don't know if I can get rid of this. Maybe I can. Who knows? Nope. Alright, anyway. I've got 0 equal to x plus 2. Of course, if you solve it, you subtract 2 on both sides. You're going to have negative 2 equal to x. So let's remember this. Okay? And then if you move the, you cover up the other one, right? Then your equation is 0 equals x plus 1. So let's solve that equation as well. If we solve that equation, 0 equal to x plus 1, right? You would subtract 1, and you'd have negative 1 equal to x. So let's remember this as well. So now I have two values for x. I've got negative 1 and negative 2. So now what I'm going to do is first get this rectangle out of my way. I don't know how to erase it, but there it is. And now what I'm going to do is I'm going to plug these numbers in to one of the equations. It doesn't matter if I plug it into the first equation, the quadratic, or if I plug it into the second equation, the linear one. But I'm going to plug it into the linear one, the second equation, because it's a little bit shorter, so it's going to be a little easier. So let's plug in those two x values, but one at a time. Let's use x equal to -2 first. We'll have y equals to, this is the equation I'm using, x plus 1, but I'm plugging in -2 for x. Alright, so I plugged in -2 for x, now -2 plus 1 equals -1. So that's the answer. We're going to have x was -2 and the y was -1, so that's the point we're using. Alright, now if I use the other one, x equals -1, let's plug that in. Right? We're using the same equation. I'm plugging in -1 now. Okay, for x. And now I have -1 plus 1. So y is going to equal 0. Right? Because -1 plus 1 is 0. So that means when x is -1, y is 0, and I have that point. So here are those x values that I found that I plugged in, right? And when I plugged them in, I got these y values out, and those are my answers. So my answer would be A, it looks like, option 1. All right. This is exactly the same process, so let's do this together, except a little bit, the setup's a little bit different because we need to get that second equation in slope-intercept form to make this easier for ourselves. So our second equation, we have, it's, oops, I need to get this, here we go. Second equation here is 3y minus 6x equals 6. I want to get the y by itself, so let's move this 6x to the other side real quick. Now keep in mind that, well, we're going to have 3y on the left here, but 6 plus 6x, those are not like terms because only one term has an x on it, the other one doesn't. So I can't really combine them together. I'm just going to have those two terms over here. So you can write 6 plus 6x, but I'm going to write 6x plus 6. I just like to have that x before the x term before the constant term. That's just my preference. And it's going to help a little bit later as well if we write it in that order. But we just have those two things over here, the 6 and the 6x. Now I want to get rid of this 3. I'm multiplying it, so let's divide everything by 3. That'll get the y by itself, which is what I want, equal to 2x plus 2. So let's remember this equation. Let me just go ahead, erase the equation that was there. Okay, let me erase all of this just so I have a little bit more room. So the equation is 2x plus 2. Y equals 2x plus 2. I'm going to replace this equation with that. So we're going to have y equals 2x plus 2 instead of what was there before. It's the same equation except in a nice, easier format. So now we're going to do exactly what we did to begin with last time. I'm going to write these equations out, and I'm going to subtract one from the other. So y equals and then 2x plus 2. Remember, I'm leaving that gap there because that second equation does not have an x squared. But I'm subtracting this second equation. So I'm going to subtract everything. Y minus y is going to be 0. X squared minus nothing will still be x squared. Keep in mind we're still subtracting here. 3x minus 2x would be just 1x. And -4, be careful, you're subtracting. -4 minus 2 will be a -6. You have to be real careful there because you have to remember that you're subtracting those. Alright, but here's the equation that we need to factor now, or again, you could use the quadratic formula, but I'm going to use factoring simply because it's going to be a lot faster. So the a value is 1 here, the b value is also 1, and then the c value is -6. So remember when you factor, you use this x thing, you have a times c, which would be 1 times -6, so that would be -6. And then down here you put your b value, which is 1. So now you need two numbers that multiply to -6 and add to 1, which would be 3 and -2. 3 times -2 is -6, and 3 minus 2 is 1. So that would make this x plus 3 and x minus 2. Right? I'm just plugging in the positive 3 and the -2 into my factored binomials. You always have the x's there. You just simply would put these two numbers. They would always change in terms of whatever these numbers were. You simply just kind of plug them in. So remember, you have two equations here. Let me use my fancy rectangle again. and cover up one of these. And now you see one of the equations is 0 equals x plus 3. So what we're going to do is solve that. We have 0 equal to x plus 3. If I subtract 3, I'll have x equal to negative 3. Let's keep that in mind. And then the other equation, we move this here, I have 0 equals to x minus 2. So let's write that out. We have 0 equal to x minus 2. Let's solve this. You add 2 to both sides, and you get 2 equal to x. So I've got these two values of x. Now what I'm going to do is plug in these x's back into my equation. So remember from the equation in the beginning, I can plug it into either of these, it does not matter. But I'm going to plug it into the second equation because it's a little bit easier. So the second equation was y equals 2x plus 2. Let's start with this negative 3. Let's plug that in first. We'll have y equals 2 times negative 3 plus 2, which would be y equals to negative 6 plus 2, which means y equals negative 4. So that means one of the answers is, let's see, when x is negative 3, y is negative 4. So remember that's the x that I plugged in. This is the y value that I got out. So that's one answer. And that's probably enough because it's multiple choice. It's probably going to be answer A. But let's just show you that we're going to get the 0.26 from the other one. So the other x value is 2, so let's plug that into the same equation. We're going to have y equal to 2x plus 2. Let me erase this so it's not in my way. Y equals 2x plus 2. Let's plug in, x equal to 2 now. So that's going to be 2 times 2 plus 2. So that would be y equals to 4 plus 2, which means y equals 6. So that means when x is 2, y is 6. Remember that's the x that I plugged in. This is the y I got out. And of course, as I mentioned, we've got the answer there, option 1. Alright, let's continue. Those are the big problems right there. Oh, well, this is also a big problem. Alright, this is a doozy, but we can handle it. Now, what we have to do is we need to set up a system with two equations with 2 variables. So I'm going to put off to the side over here. Let's leave it in. Let's put it in blue, actually. The 2 equations with the 2 variables that I'm going to have. Alright, so these are the equations that I'm looking to find. Now, look at my system. I already see an equation that has 2 variables, right? It doesn't have all 3 variables. It only has the y and the z. So let's use this. However, let's kind of rearrange it a bit. Actually, let's go ahead and rearrange all of these first. All of these want to kind of look like ax plus by plus cz equal to whatever our constant is at the end. I'm just going to call that d. But we want basically the x, y, and z on the left side, and then the regular number on the right side. So the first equation, that means I need to move the negative 9z over to this side, which means I'll add 9z to do that. So that equation would have, and I'm also going to put the 3x in front of the 4y. So the first equation will be 3x plus 4y, and then we're adding the 9z over there. So we're going to have plus 9z equal to negative 51. So that's going to be my first equation. Let's kind of put that, I guess we'll write it over here. Got 3x, put it somewhere on your paper off to the side for now. 4y plus 9z equal to negative 51. Alright, I'm going to erase that, and let's do the second equation. Now the second equation, it's got the y on the right side, and we need to move that y to the other side. So that means if it's plus y, we would subtract it. So that's going to leave that equation as a negative y, because we've got the minus y on that side now, minus 5z equal to 24. So that's what that equation would look like if you just move the y to the left side. So let's write that over here. We'll have negative y minus 5z equal to 24. And then, let me erase this. And and the last equation is already set up. So it's already got the x, y, z in that order. So let's just kind of copy that down for now. Let's put it over here at the others. Negative 11x minus 7y minus 12z equals to 55. Alright, here's what I'm going to do. I'm going to make this a little bit neater. Let's erase this. We don't need that anymore. Let me use a little rectangle tool. Alright, to cover up what was there before. Alright, and hold on a second. Oh, come on. Alright, let's make that over here. Let's copy this and move it over there. Yeah. Just, I thought it was going to stay there, but I guess that's hiding it. I was going to cover that up, but I guess it doesn't work that way, does it? Alright, fair enough. You got me. Let's just move it off to the side here. Let's leave it right here. We'll just cover this up so that we don't see it anymore. So this is the new system. It's the same exact system as before, just rearranged a little better. Now, like I was saying, the second equation already has just two variables, right? It doesn't have an x, so let's keep this equation off to the side for a minute. We're going to need this. Because remember, the goal here is that we have two equations with only two variables. And there's already one equation with two variables. Now I just need to find one more equation with two variables. So what I'm going to do to get that is I'm going to take these other two equations, I'm going to line them up and cancel these things out. So, and use the elimination method. So let's go ahead and write those two down. We have 3x plus 4y plus 9z equal to negative 51. And then the other equation is negative 11x minus 7y minus 12z equal to 55. All right, so I'm going to use the elimination method. Now that means I need to try to cancel out the x's or y's or z's, but notice that the equation we chose to the left has y and z, so let's eliminate. We need to eliminate the x variable here. So let's multiply the top equation by 11 and the bottom equation by 3. Now I did that because that's going to make 33x on top and negative 33x on bottom, so when I add them, they'll be able to cancel each other out. So let's multiply the top equation by 11. That would give me 11 times 3 would be 33x. 11 times 4 would be 44y. 11 times 9 would be 99z. And 11 times negative 51 would be negative 561. Now the bottom equation, 3 times negative 11 would be negative 33x. 3 times negative 7 would be negative 21y. 3 times negative 12 would be negative 36z. And then 3 times 55 is 165. So let's add these together. Now you see 33 minus 33, those are going to cancel out. 44 minus 21 would be 23y. 99 minus 36 will be 63z. And then negative 561 plus 165 will be negative 396. So let's take this equation, because now I've got an equation with just two variables, right? So let's use that, let's put it over with the other equation that has two variables. We have the 23y plus the 63z equal to the negative 396. All right, again, I'm going to keep erasing these things, but you can still keep them on your paper. I just need more room on my board here. All right. Now we're going to use elimination method on that system and find out either y or z. So let's see, we've got negative y. I'm just going to copy them down. You don't have to do this again. I'm just going to do this because I have more space over here. The first equation, I'm just rewriting it. The second equation, I'm just rewriting it. 23y plus 63z equal to negative 396. Now, same exact process that we just did, elimination. Now, let's multiply. This is just my choice, but I'm going to multiply the top equation by 23. Because that'll make a negative 23y, and I already have a positive 23y on the bottom it would cancel with. So let's multiply top equation by 23 so it can cancel with the second equation. 23 times negative y will be negative 23y. 23 times negative 5 will be negative 115 z. And then 23 times 24 is 552. Alright, and the other equation I'm just going to leave it the same for now. 23y, 63z. So a lot of this is just recopying things down. I'm only doing it to try and keep a little bit neat. But now I can add these equations together. So negative 23 plus 23, those cancel out. Negative 115 plus 63 would be negative 52z. 552 minus 396 will be 156. And now all I have left is to solve for z. Because I don't have any y's, I don't have any x's. All I need to do is divide by negative 52. And I'm going to get z equal to negative 3. So there's already part of my answer, z equals negative 3. So let's go ahead and put that over here. I've got one of my answers. Now it's going to be a little bit easier. I didn't mean to erase that part of the equation up on top, but it's okay. Now I know what z is, so let's plug in z to find y, or x. So I have those two equations over here on the left. It doesn't matter. Let's use one of them. I'm going to use the first one. It looks a little bit simpler. But the first equation is negative y minus 5z equal to 24. But I'm plugging in negative 3 for z now that I know that, right? So I'll have negative y minus 5 times negative 3 equal to 24. So this would be negative y plus 15 equals 24. Because negative 5 times negative 3 will be 15. We can subtract 15 on both sides. We'll have negative y equal to, this is 24 here. 9, and then we can divide by negative 1. You'll get y equal to negative 9. So there we go. We already have a second answer, just like that. Y is negative 9. And now lastly, we'll do that one more time to find the x. So we're going to have to use one of the original equations. I'm going to use the very top one, the 3x plus 4y plus 9z equals negative 51. And again, I'm just going to plug in the y and the z, and then evaluate and find x. So that's going to be 3x plus 4 times negative 9 plus 9 times negative 3 equal to negative 51. So this would be 3x, 4 times negative 9 would be negative 36, 9 times negative 3 would be negative 27 equal to negative 51. So now let's add 36 to both sides. And let's also go ahead and add 27 to both sides. That way I can cancel these two things out, and we'll just have 3x on the left equal to whatever negative 51 plus 36 plus 27 is, which I believe is 12. And then you would divide your 3, you'd have x equal to 4. Finally, just like that, we've answered our system. So it takes a lot longer to do by hand, but it is possible. I recommend, I'm doing this for you just for that, so you have that benefit. It's not going to be too, it's a lot, it's overwhelming, I get it, but we did it together. That's the main thing. Alright, we can do this last one together as well. It won't take as long because the setup is already there for us, but we're going to start by using the elimination method again. So notice, we're going to try and do the same thing we did before, and try to make two equations with two variables. So I'm going to put that little box over here. And this is where I'm going to put my two equations with two variables. Now, I don't have any equations with just two variables right now. All three of them have all three variables, x, y's, and z's. So I need to make both of these equations from scratch. So I have a little bit of freedom here in terms of what I want to eliminate and how I go about it. But let's just choose a variable to eliminate. I'm going to choose to eliminate x, and I can pick any two equations I want to try and eliminate x. So I'm going to pick the first two, or I'm sorry, the first one and the third one. If I choose those two equations, you'll see what happens and why I chose them. But that's the first equation. Now let's write that last equation right below it. Now if you're paying attention in the last question, you'll already know why I chose these two and why I'm eliminating x. Because those two equations are already set up where if I add them together, they'll eliminate x. 2x minus 2x, that's going to cancel out and leave me with no x's. So now I'll just have y's and z's. Y, or 1y, minus 4y is going to be negative 3y. 4z plus z would be 5z. And 29 minus 3 is 26. So there, just like that, we have one of the equations. I've got negative 3y plus 5z equals 26. Now I'm going to do the same exact thing one more time. Let me erase what I've got here, just so I have a little more room again. I'm going to start completely from scratch and pick two other equations and try to eliminate the x again. Because I eliminated x the first time, I have to eliminate x again. It has to be the same variable both times. So it doesn't really matter. I'm going to choose the second equation and the third equation. Let's use those. I'll have x plus 5y minus z equal to 7. And then the negative 2x minus 4y plus z equal to negative 3. Now I have to eliminate x's. I know I could eliminate z's right now, right? Because that'd be super easy, but that would be useless because I need z in my equations, right? Because my equation over here doesn't have x, so my other equation would also not have x. So we need to eliminate x. So let's, obviously the second equation is already negative 2. Let's multiply the first equation by a positive 2. And that will make a 2x, and then a minus 2x already would cancel. So let's multiply the first equation by 2. That will be 2 times x is going to be 2x. 2 times 5y is going to be 10y. 2 times negative z will be negative 2z. And then 2 times 7 is 14. And then the second equation, I'm going to leave it the same because it already has negative 2x, which is going to cancel with my newly created positive 2x in the first equation. Alright, so let's add them up. These cancel out. 10 minus 4 will be 6y. And negative 2z plus 1z will be negative 1z equal to 14 minus 3, which is 11. So I've got 6y minus z equal to 11. Alright, again I'm going to erase this so I have a little more space. But now I've got those two equations. And I'm going to use the elimination method again to solve for either y or z. So let me write them down. I've got negative 3y plus 5z equal to 26. And then 6y minus z equal to 11. Now, there's two ways you can go about this. I'm going to multiply. Now, obviously, the y's right now don't cancel, and the z's don't cancel. But what I'm going to do, I'm going to go ahead and multiply the second equation by 5, because that's going to make a negative 5z, which will cancel with the positive 5z I have in the previous equation. There's other ways you could do this, but that's what I'm going to choose to do. And let's go ahead and go with that. So if I multiply the second equation by 5, that'll be 5 times 6 will be 30y. 5 times negative z will be negative 5z. And 5 times 11 is 55. And the other equation, I'm going to leave it the same. It's already negative 3y plus 5z equal to 26. And again, now you can see that those equations, the z's are going to cancel out. So 30 minus 3 will be 27y. The z's cancel out, and it equals 55 plus 26 would be, I want to say, let's see, 65, 75, 81. And then if you divide by 27, you'll get your y. So 27, y is going to equal 3. Alright, so y equals 3. Look, that's already an answer choice there. So we're going to select it. Now it's much easier to find x and z because we already have this information. So let's take one of those equations, one from over here on the side, and let's plug in that 3 for y. So I'm going to use the second equation. So we have the second equation, 6y minus z equals 11. I'm going to plug in 3 for y now that I know y is 3. So 6 times 3 minus z equals 11. So this will be 18 minus z equals 11. We can subtract 18. This will get me negative z equal to negative 7. And then, of course, if you divide by negative 1, you'll have z equal to a positive 7. So there's that answer. Now all we need is x, and we can use any of the first 3 equations to find x. I'm going to use the second equation. It does not matter at all, but I'm just using it because the x is kind of already by itself. It doesn't have any number next to it, so I'm going to use that. Let me go ahead and erase some of this so it's not in my way. Alright, but the second equation is x plus 5y minus z equals 7. Now again, I already know y is equal to 3 and z is equal to 7. So just plug them in. We'll have 5 times 3 minus 7 equals 7. Oh, this is plus, by the way. Okay. So this will be x plus 15 minus 7 equals 7. I can add 7 to both sides. To get rid of that, I'll also subtract 15 from both sides. I'm just going to do them both at the same time, if that's okay. So we'll have x equal to 7 plus 7 is 14. Then minus 15 would be negative 1. So x equals negative 1. There you have it, all 3 answers. It's obviously a bit of a process. Calculator's a little bit faster, but there you go. That's going to cover it, guys. Thanks for putting up with me throughout this process. I hope that encourages you to get a graphing calculator because I'm sure you can see how much you wrote down. Alright, we'll see you in the next one. Good luck on your quiz, and have a good day.